Hello, I'm Ben. I'm an instructor at Chicago Bright, and today we're going over another math problem that was on the University of Tokyo entrance exam back in the 1950s. With this problem, we have a bit of an issue with trying to think about polynomials, but this problem actually is generally pretty simple. But the difficulty comes from us overthinking about the problem, trying to think of maybe even just one step to solve it, rather than trying to find pieces of information that we can kind of pull out from the problem. So what we want to do with these type of problems is to first calm down a bit, right? We have to understand that all these problems should be solvable. None of them are going to be talking about any type of knowledge that we have no clue of, such as calculus or linear algebra. This problem is only going to require anything you've learned in Algebra 2 and nothing past that. So we should be able to solve this type of problem. And the SAT does not push anything past the geometry or Algebra 2 either. So there's no reason for you to be scared of the questions they're going to give you and think that they're giving you information that you don't know about. Most likely you actually do know what you have to do to get the answer, but what's causing you to not be able to do it is just because you're lacking confidence. So what we want to do is to go through practice, try to do these problems multiple times so that we feel confident in trying to solve these problems. And that's how we can improve our score. So with this first problem, we have that 3 roots of the cubic function x cubed minus blank x squared plus 25x minus 26 is equal to 0 is 2 blank plus blank I and blank minus blank I. Okay, so we are immediately kind of told, okay, well, we have some type of cubic function and it has some roots, which is obviously the case where we probably learned that any polynomial, depending on its highest degree, is going to tell us how many roots that it actually has, whether they be real or unreal. Now, when we look at this problem, the first thing we want to think about is, okay, we have a missing number here, we have 1 root given to us, and we have 2 imaginary roots. So we can kind of do a few things with this information. Well, the first thing I would probably want to think about is there any way to solve this problem, right? How do I get this value? Because without getting that value, I think that finding anything else, like anything involved with the other roots that we don't know about, will be very difficult. So my first question would be, okay, how do we deal with finding this unknown constant in front of x squared? Well, let's first write out in a way that we can kind of play around with algebra a bit. So by calling it A, we can kind of easily try to deal with the problem a bit more. Now, one way people can think about this problem is by, let's say, dividing the root of 2, or in this case, x minus 2. So let's say we divide this whole thing by x minus 2. And we obviously can do it to the other side, but because it's 0, if we divide it by x minus 2, we don't get much of a different answer. But if we look at how we do this, well, I guess we could solve it, right? We can do long division, and then we're going to be left with some variables, right, at the end, and we just need to make sure that it equals 0, because if this is a root, if we divide the factor by it, we should still get a remainder of 0. But in this case, I think that this might take a lot of time, and there's actually an easier way to solve this problem. And so since we know we can divide by x minus 2, we actually can do something else. We can use a remainder theorem to our advantage. In other words, that means if I put 2 in this function, then I should still get 0. So if I were to do that, let's say 2 to the power 3 minus a 2 to the power of 2 plus 25 times 2 minus 26 is equal to 0. Well, we can just kind of start to solve this out a bit. Okay, so from here we can easily realize that a has to equal 8, and that now gives us our first blank. We know that this function is just simply x cubed minus 8x squared plus 25x minus 26 equals 0. So that's our first problem solved. We now actually know what this function is. Well, the next problem we had to deal with is what are the imaginary roots it has. Now, as I said, we don't want to necessarily panic and try to think of some quick way to solve the problem. We just want to step back a bit and figure out what we can do from here. One thing people might immediately suggest is using something like a cubic formula if they are familiar with that. However, if we use a cubic formula, first off it's a very long formula and it's very difficult to memorize it. And in addition to that, it might not actually be necessary to solve this problem. Well, what we know is, what if I were to divide by this root that we know about, 2? So we divide this by x minus 2. What we'll get is we'll get some type of quadratic function, right? Because we're dividing a 3rd degree polynomial by a 1st degree polynomial. That would just give me a 2nd degree polynomial or a quadratic. And then from there, I can use a formula that actually a lot of us are very familiar with, which is the quadratic function. So let's first deal with trying to divide this out. So if you're familiar with synthetic division, you can also use that. But for our purposes, we can just simply use long division. And this is actually a nice check as well. It's to confirm that we actually did pick the right constant in front of x squared, because by doing this we realized that the remainder is 0, which makes sense because it's a root. So now we have what's left over. In other words, if we were to write this out as a full function, we can somehow see it as like this. Since we have this, and what we just solved for is if we divided x minus 2 to this side, we now have that x squared minus 6x plus 13 is equal to x minus our first imaginary number times our second imaginary number. Now, always trying to find out how we can multiply this out is going to be difficult, so instead we can just use a simple equation. We just use the quadratic formula to solve the rest of this. So in this case we just say a is 1, b is negative 6, and c is 13. So if we say x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, we just need to plug in the values at this point. So negative b, which just gives us 6, plus or minus the square root of 36 minus 4a is 1 times 13, which is c, all over 2a, which is just 2. And we can just divide out the 6 and 2 gives us 3, plus or minus the square root of 36 minus 52, all over 2, which is just the same as saying 3 plus or minus the square root of 18 is, no, 16, negative 16 over 2. Now, obviously, we can kind of get rid of if we take the square root of a negative number, it doesn't normally work. But we can pull it out by using an imaginary number, which would just give us 4i over 2, or 3 plus or minus 2i. So that actually gives us both our values of both the plus and the minus, since we have plus minus. So this is just 3 and 2, and this is just 3 and 2. And this just solves our problem. And if we really need to verify, which I feel there's no reason to, we can always multiply all these together to realize that we'll still get the same polynomial. So you can actually see this problem actually didn't require any difficult methodology or any different knowledge that most people would not be familiar with. This actually used very simple understanding of roots, polynomials, of quadratic functions, and that's all we needed to actually solve this problem. And this is how we want to approach any type of math problem on the SAT or any type of problem you'll see in school. None of them are actually meant to be very difficult. Rather, it's just a test of do you actually understand what's going on? And can you break down what you need in order to get the right answers? So one thing to take away from this video is to kind of slow down, to kind of understand what you're trying to do and what type of information you'll get from doing certain things. And from doing that, it should be much more clear on how you can solve these type of problems. And if you have any questions, leave them down in the comments. And if you want more information, feel free to visit chicagobright.com.